So if we look at a worked example of a redshift calculation, in this example we're told that the wavelength at rest is 656.3 nanometers, and the observed wavelength for a distant galaxy is 659.6 nanometers. Calculate the redshift, and then we'll use that to find its recession speed. So Z is lambda naught minus lambda r divided by lambda r. Incidentally, that's in the formula sheet. It is written as lambda without an O and lambda with an R rather than these sorts of words. Plugging in the values, then we can keep them all in nanometers because we're doing a ratio of them. And we get that Z is 5.003 times 10 to the minus 3. We're keeping it to 4 significant figures incidentally because that's the same as the data given in the question. Redshift, notice, doesn't have any units as well. Then we're asked to find its recession speed. So this is a formula then, Z equals B over C for that. So Z is 5.003 times 10 to the minus 3. So V over C is equal to that. And as a percentage, that can be written as 0.5003%. Much more commonly, you'll just be asked what that is in meters per second. So you can plug in that C is 3 times 10 to the power 8, rearrange to get V 1.5 times 10 to the 6 meters per second. And this time we've got the 3 significant figures because we used C, and that was 3 significant figures. Comment on the speed of galaxy B, for which the measured wavelength of the line is 653.0 nanometers. Now you could just launch into another calculation there, and what you would get actually is a negative velocity and show it's coming towards us. Or you could look carefully at the values given and see that the 653 is the same difference below the original rest as this one is above it. i.e., if you did go ahead with the calculation, you would get the same change in wavelength, but coming towards us. So that galaxy would be approaching us 1.5 times 10 to 6 meters per second.